Hello, everyone, and welcome back to If It's Math. Today, we're concluding our series on real numbers as part of our Fundamentals of Algebra content. So far, we've gone through set notation, common number sets, properties of real numbers, graphing points on a number line, what inequalities are, and how to graph them. So, in this video, we're going to finish up our content on real numbers by learning about absolute values. So, by the end of this video, you'll understand what absolute values are and how to use them to find the distance between 2 points on a number line. So let's go ahead and get started. So when we think about absolute value, what absolute value represents, the easiest way to understand it is how far is a number from zero. So that's all that absolute value represents. When you think about positive numbers, that's kind of intuitively how we think about it. So we say the number 3, well, that's 3 from 0, so the value of that is 3. When you talk about -3, it gets a little more complicated, right? So it's still kind of worth 3 if you think about the 3 component, and that negative just tells you what direction it is. But if you're thinking an absolute value, this -3 is the same distance from 0 as +3. So that is this concept when we look at absolute value, that 3 and -3 are the same distance from this 0 point. So the way you represent that is through absolute value symbols. And so those are these upright lines. So when you think about what that represents, if we have the absolute value of 3 here, well, by definition, again, that's how far is a number from 0. So we know that the absolute value of 3 is going to be 3 because it's 3 places away from 0. But by the same token, if you look at the absolute value of -3, that is also going to equal 3. Because how far is it from 0? 0, you've got 1, 2, 3 places. So that absolute value is +3. So if we think about putting that into a definition, what that tells us is that the absolute value of x equals x if x is greater than 0. And then the absolute value of x equals -x if x is less than 0. So that is the actual definition of absolute value. That absolute value of x is x if x is greater than 0, and the absolute value of x is -x if x is less than 0. So then you get some rules that get thrown in there when you think about what this really represents. So when you think about it, it's going to tell you that the absolute value of x is greater than or equal to 0 always. There is no scenario in which the absolute value of x is negative. The absolute value of 0 is 0, so it could be 0, but the absolute value of x is always going to be greater than or equal to 0. Another one that this gives you is that the absolute value of -x will always equal the absolute value of x. That is another firm rule. So if you think about the example we did before, the absolute value of -3 is the absolute value of 3. Those two things are going to equal the same. So one more rule is that if you have the absolute value of a minus b, that is going to be the same thing as the absolute value of b minus a always. There's no scenario in which that's not true. So these are 3 really important rules. So absolute value of x will always be positive. That's what this one tells you. The absolute value of -x will always be the absolute value of x. And then when you take the absolute value of the difference of two numbers, it doesn't matter what order you've taken that difference. So a minus b, the absolute value of a minus b, will always be equal to the absolute value of b minus a. So let's practice on a few of these. They're pretty straightforward, but it's important to look at all the sort of complexities that could come out. So if you have the absolute value of -1, remember the absolute value of a negative number is just the positive of that number. So the absolute value of -1 is 1. We have the absolute value of 7. Well, the absolute value of a positive number is just that number. So that's going to be 7. If we have the absolute value of -2.6, again, you just drop the negative. So that is going to equal 2.6. Now, these are some examples of when you have to really make sure you're paying attention to what's represented. So if you have negative absolute value of 3, well, we know that the absolute value of 3 is 3. So then you put the negative there, that's actually -3, because this is like -1 times the absolute value of 3. So if you have negative the absolute value of -2, that's going to be the same as -2. So -2. So sort of the key with these, again, the absolute value of a negative number is just the positive of that number. The absolute value of a positive number is just the positive of that number. Same thing here. It's no different with decimals. The absolute value of a negative number is just the positive of that number. And then these last ones are where it got tricky. So we have a negative times an absolute value. So the absolute value of 3 is just 3, but then you have this negative to give you -3. Then with this one, we have negative the absolute value of -2. Well, the absolute value of -2 is just 2, but then you still have this negative to take care of, so it's going to be -2. Okay, so sometimes what you're going to be asked to do is simplify expressions that have absolute values in them. So the key to this is looking at, is what's inside the absolute value going to be negative, it's going to be positive, or can you not tell? If it's positive, what's inside the absolute value, you just drop the absolute value symbols, right? It's consistent with those rules that we just went through. If what's inside the absolute value is going to be negative, then you multiply the entire expression by -1 before you drop those absolute values. And then we'll look at an example in a minute where if you can't tell if it's going to be positive or negative, then you just leave it alone. You can't simplify it any. So let's look at a few examples. So, we know that pi is equal to about 3.14. It's approximately equal to that 3.14. So if we have the absolute value of pi plus 1, well, we know that pi is a positive number, 3.14. If we add 1 to a positive number, it's going to be positive. That's not going to become a negative number at all. So we know that that is just going to be equal to pi plus 1. You don't even need the absolute value symbols. But what if we were doing something a little different? Let's say we had the absolute value of pi minus 7. Well, pi again is 3.14, or around 3.14. So if we do 3.14 minus 7, then we know that that's going to be negative because the negative part is bigger than the positive part. So the answer to this is going to be negative. And we know from our rules what you do is that you multiply the whole expression by a negative. So that's the equivalent of a negative times pi minus 7, which gives you negative pi plus 7, which is going to end up with 7 minus pi. So there's a bit of a shorthand there. If you're going to be multiplying two numbers like this, where one is subtracting the other by a negative, actually all you have to do is flip it around. So if you're saying the absolute value of pi minus 7 and you know this is negative, that's going to be 7 minus pi. Let's look at a few more examples. Let's say that you had the absolute value of x plus 7 if x is, let's say, greater than negative 4. So again, what you have to do is do a little bit of logic, right? So x plus 7, if we're saying x is greater than negative 4, well, if this is, say, 10, 10 plus 7 is going to be positive. So the smallest this can be is negative 4. And because negative 4 plus 7 is going to be 3, which is positive, you know that every answer that could be in here is going to be positive. So what that tells you is I can just drop the absolute value sign because it's always going to be positive. So then let's look at one more. What if we have the absolute value of 3 minus x if x is greater than 4? Okay, so we're kind of in the opposite scenario, right? So if you think about the numbers, if we have 3 minus x, if x is greater than 4, we know that, say, we had 3 minus 10,000. That's going to be very, very negative, right? But even at 4, 3 minus 4 is going to be equal to negative 1. So every outcome here is going to be negative. So remember what we do then is you multiply the whole expression by a negative. So that's going to give you negative 3 plus x, which is x minus 3. Or again, the shorthand is if you know that 3 minus x is going to be negative, then you just flip it around. But what if you can't tell, right? So it might not always work out nicely, like the examples that I just gave you. So what if you have the absolute value of x plus 7 if x is greater than negative 9? Okay, so let's write this out because we're going to do a little more math on this one. So let's say that, what do we say? Let's say x is 10. So if x equals 10, x plus 7 equals 17, which is positive. But if x is negative 8, then we'll have negative 8 plus 7, which is negative 1. So that is negative. So what that tells us is, okay, well, there's some numbers where it's going to be positive. There's some numbers where it's going to be negative. So you can't simplify this any. So you just have to leave it as the absolute value of x plus 7. There's no way to simplify that down because the parameters you've been given for it show you that, can't tell. Okay, so now we're going to get into a bit of an application with how you do distance on a number line. So really, the way you do this is if you want to know how far apart two numbers are on a number line, it is just the absolute value of the difference of those two numbers. That's all there is to it. And again, because you're using absolute value, the order of the numbers doesn't matter. So if you're looking for the distance between the number, say, x equals 7 and y equals 3, and you want to know the distance between those on the number line, just do x minus y, which is the absolute value of x minus y, which is the absolute value of 7 minus 3, which is 4. So let's practice some of these. Let's say that you have x equals 3 and x equals 9. So again, it's just the absolute value of the difference, absolute value of 3 minus 9, which is going to be the absolute value of -6, which is 6. And just to prove it to you, let's show that it doesn't matter which way you do it. 9 minus 3, that'd be the absolute value of 6, which is 6. So let's try another example. If we have x equals -2 and x equals 3, what we'll end up with is the absolute value of -2 minus 3, which is the absolute value of -5, which is 5. And again, just to prove it, if we'd done it the other way and done 3 minus -2, that's going to have the absolute value of 3 plus 2, which is the absolute value of 5, which is 5. Let's do one more for good measure. So if we have x equals -1 and x equals -8. So the absolute value of -1 minus -8 is going to equal the absolute value of -1 plus 8, which is the absolute value of 7, which is 7. And then let's try it the other way just to prove it. If we had -8 minus -1, it's going to be the absolute value of -8 plus 1, which is the absolute value of -7, which is 7. Now, you don't have to do this twice. Whenever you're given this as a problem, you really just need to do it one way. I just wanted to show you that no matter what direction you put them in, you end up with the same number. So you can pick whichever way actually makes the math easier for you. You got a bunch of negatives involved. Sometimes it makes sense to put one before the other. And all you really need to remember is that it doesn't matter what order you start out in. Remember, the absolute value takes care of it. That's one of the rules that we learned. Okay, so let's just summarize really quickly. Remember that the absolute value is how far a number is from 0 on the number line. So the way that that works is that the absolute value of x is x when x is positive. The absolute value of x is -x if x is negative. Alternate way to think about that is you just drop the negative sign. The absolute value of x will always be positive. And the absolute value of -x is the same thing as the absolute value of x. And then we use this a lot in those previous examples. The absolute value of a minus b is the same as the absolute value of b minus a. And then if you're wanting to calculate the distance between two numbers on a number line, you just take the absolute value of the difference. And again, the order doesn't matter because of this rule that we know from up here. So that's really all there is to absolute values. They're pretty straightforward once you get used to the fact that the absolute value of a negative number is positive. That's all you really need to know. So I hope this video was helpful. Please like it if it was. Please be sure to subscribe to our channel as well to be the first to know about new content. And always remember that if it's math, we have the solution.